what's up, people? So this is Rob, and this is an introduction to statistics for the psychological sciences. We are entering into the fourth lab video. And in this video, we are going to learn how to conduct correlation, Pearson product moment correlation tests in SPSS, and as well as other associated tasks involved in that, like making scatter plots of variables. So I have something fun for today. I took some time and I downloaded some disparate sources of data. So the first bit of data that I obtained was temperature data, the average mean temperature in the Atlantic Ocean for every year from 1886 all the way up to 2016. I received this information from the NASA Jet Propulsion Laboratory at the California Institute of Technology. And then I also pulled data from the National Oceanic and Atmospheric Administration, NOAA, data from something called their HERDAT data set, which is this is from like the hurricane branch of NOAA, where they record the number of hurricanes that have occurred every year. Now, one thing that is challenging is, well, you know, they didn't really have complete data before 1960 something. I mean, whenever satellites happened, you know, that it was pretty easy. But what they used to do is track it with ships, and they would miss certain data. But thankfully, there is a publication in the Journal of Climate by Vecchi and Knutson. And what they do is they estimate annual numbers of Atlantic hurricanes missing data from this specific data set from 1878 to 1965. And they do it by using ship tracking density. And so basically, like before there were satellites and things, what they did was they used shipping data to try to estimate some of the missing data in this massive hurricane data set. And so I took both the temperature data and the hurricane data, and I combined them together so that, you know, well, if we know that pirates might not be an accurate predictor of, you know, hurricanes and the effects of global warming, then maybe we can look at what some of the scientists say, right? And actually run some correlation analyses on real data. One thing that's going to be typically good to do is you're going to want to just kind of get a sense of what the correlation might be by running scatter plots. Now, scatter plots, obviously, like the variable year, for example, that's not going to follow a normal distribution, right? That should kind of make intuitive sense, right? It's just one year after another. So you can't run a correlation with the year variable because it's not normally distributed. But we can run scatter plots. And so I thought we'd start off and I'd just show you how to conduct or how to produce scatter plots in SPSS. And we're just going to do it in the most simple way possible. So this data set is available for you. You can download this. It comes along with this lab video. So I would encourage you to, you know, hit pause if you need to and download this file, open it up and go through it with me. Okay. So let's start and let's just look and see if there is a what the scatter plot looks like when we look at year and actual temperature. So I would say that, if we were going to have a hypothesis, we would probably predict that as year increases, temperature will also increase. And so why don't we test that? Year is going to be our X variable because it's the predictor, and temperature is going to be the Y variable because it's what we're trying to predict. Okay, so let's say graphs, and then go down to legacy dialogues, and then go over and all the way down here to scatter/dot. And we're going to do a simple scatter plot. And then click define. You're going to have something like this. So let's put year on the x-axis, and let's put temperature on the y-axis. And so what I would expect to see from this is that as year increases, so does temperature. So we should have something that moves kind of up and to the right. Okay. And here we go. So we can see down here in the 1880s, right, temperature was relatively low. And then as years went on, there's some kind of spike going on in 1940, 1945, around there. And then it just kind of continues this pattern. It starts picking up pretty quick, especially after the year 2000. So there it is. All right, well, why don't we pull a scatter plot that examines year or that examines temperature and the number of hurricanes. So we go to Analyze, just doing the same thing again, just trading out a variable. We go to Graphs, Legacy Dialogues, and then Scatter dot, Simple Scatter, Define. And then we can just take out year. Actually, we'll take out both because we want the number of hurricanes to be what we're predicting and temperature to be the predictor variable. And then, okay. Well, look at that. So as temperature increases, I would say this looks like, obviously the majority of the time period between, roughly 1880 on, the majority of the time period, everything has been normal. But when the temperature is higher, we tend to see more hurricanes. Kind of unsettling. Okay. So now let's run a test. Let's see if temperature and number of hurricanes are correlated with each other. So we can go to Analyze, and then Correlate, and then Bivariate. And we're going to put in the temperature and the number of hurricanes. And you see down here, we have the option for Pearson, which is what we're going to do because these are normally distributed data. And it does look like there is a somewhat linear relationship from the scatter plot. You could model this with a line. And you notice that there's also two other options. There's Kendall's tau and the Spearman. We briefly mentioned the Spearman. The Spearman assesses monatomic relationships. So let's run this. Now, if we go to options, right, we can ask it to produce the means and the standard deviations, the cross-product deviations and covariances, which, if you remember, cross-product deviations and covariances went in, those are features that were in the equation of the correlation coefficient. But we won't select any of those. Let's just run a simple correlation. And we click OK. And so what it does here is it shows a kind of matrix. So you could put, 5 variables in there, and it would just test the correlation between every variable against every other variable. Now that's kind of frowned upon procedure for reasons that will become evident as we progress in the course. There are things about inferential statistics that we have not learned yet that are important. So one thing is a correlation can be used as a descriptive statistic. It can describe the relationship between two variables. However, it can also be used as an inferential statistic. Right now, we're mainly focused on using a correlation as a descriptive statistic. Later on, we will talk about how it can be leveraged to make inferences about populations. Okay. So if we look, let's look at this bottom one here. See, you notice it's a mirror image. They're the same, right? 4.454, 0.454. Now, that is quite a big correlation. I mean, that's almost in the strong category. It's extremely high for a moderate correlation. And so we can see that this correlation coefficient is positive, which means it's a direct relationship. And we can also see that, the strength of it is it's a pretty strong correlation. It's a high level moderate correlation. And so what this suggests is that as temperature in the Atlantic Ocean increases, so does the number of hurricanes. And this is on the basis of 137 years of data. So, now it's important to recognize that correlations can go in multiple either direction, right? So you could think, well, maybe it's temperature that's causing the hurricanes, but we can't make causal claims based on correlational data. This just as equally means that maybe the number of hurricanes causes temperature to go up, right? That would make sense, right? But this is just correlational. You cannot say that temperature causes hurricanes or vice versa. And you always have to be aware that there could be some lurking third variable out there that might explain why temperature is increasing and number of hurricanes is increasing. It might not, just because they share variance, they co-vary together. The next question you would ask is why, right? Thankfully, we have expert climate scientists in the United States who can address those subsequent questions. So, basically, we're pretty confident at this point, right, that despite the fact that there is a correlation between number of pirates and global average temperature, that's likely not going to be the, there's a lurking third variable out there that would explain that. On the basis of this data, global average temperatures correlated with lower pirates. Hey, maybe it's because as temperature increases, the number of hurricanes destroys all the pirate ships. Never know, right? But it is interesting data. It is rather startling to see from real data sources that the magnitude of the relationship between temperature in the Atlantic and the number of hurricanes. I'd be excited if you sought out the HERDAT data set. You can just Google it, and you could find all kinds of other weather data and line it up with, various, like temperature indices, CO2 indices. And you can do all of this correlational research on your own. So statistics, one of the benefits of statistics is it can teach you to be a more informed consumer of information. And what you do with that information is up to you. And it's my opinion that while the relationship between number of pirates and global average temperature is a real and true relationship, it does not carry much practical significance. However, it would be hard to find data that could carry more practical significance than the fact that as temperature has increased over time, so have the number of hurricanes.